Good morning, ladies and gentlemen. Today we're going to solve some trigonometric equations. And before we solve these trigonometric equations, we're going to have a review, a little bit of an algebra review. And I will tell you that half of what we do today is going to be solving simple algebra equations. And then we're going to have to reference the unit circle to solve these trigonometric equations. The first thing I want to review is the fact that the square root of x squared does not equal x. The square root of x squared does indeed equal the absolute value of x. That's going to be very important. That particular concept will be very important in solving these equations. The other thing that you'll need to know that students get confused about is this notation over here. Sine, that little 2 up there, theta, that actually means sine of theta squared. So this is just the way that mathematicians shorthand the sine squared. So you need to know now in the rest of your math career that this means the whole quantity sine squared. And it's also good to note that this does not mean this. Those are not equal. These are equal. And so then following this topic of square root of something squared, the square root of sine squared is going to be the absolute value of sine. And you will see in the top of the bill handout that I show you that the square root of cosine squared is the absolute value of cosine. But that's going to be very important to know those two topics. We will also need the unit circle information, so it's going to be very difficult to do these problems without a filled out unit circle. And it's important to note that. Okay, and then, so you're going to need the unit circle. And then also for these equations, it's going to be good to note that the tangent of pi over 3, and we know that the tangent is the y over the x. And if I get to pi over 3, that point, the terminal point to pi over 3 is 1/2 square root of 3 over 2, as I can see on my unit circle. Therefore, the tangent of pi over 3 is square root of 3 over 2 divided by 1/2. Cancel the 2's in the bottom, and that's square root of 3. That's going to be important to note, and you will need to know that. The other thing that's important to note is that the tangent of pi over 6 is 1/2 divided by square root of 3 over 2. Again, the y over the x, which simplifies to square root of 3 over 3. In like manner, the cotangent of pi over 3 is square root of 3 over 3, and the cotangent of pi over 6 is square root of 3. It's also, I'm not going to write this down, heavens to Betsy. Betsy, the tangent of any fourths, the tangent of pi over 4 is 1. The tangent of, well, 1, 4, 2, 3/4 is -1. The cotangent of pi over 4 is 1. The cotangent of 3/4 pi is -1. So it's important, that's why I didn't put those down there. And of course, you're going to need to know the sine, the cosine, the secant, cosecant. Secant is 1 over x, the cosecant is 1 over the sine. Those are things that you're going to need to know as well that are on the bottom of that, those definitions, those chair definitions, if you will. Okay, so this is just good to note that. So let's just jump right into some bill problems. And I'm going to probably, over the course of the next two days, do all of the bill odds. And then there will be several bill type problems on the test, and they will be worth multiple points, at least 2, probably 3 points, and it's going to be imperative that you show the algebra steps up to your solution. The other thing that we need to note about the bill handout is we only want the solutions for theta between 0 and 2 pi, including 0, not including 2 pi. So that's out there on the bill right there, and all of you have a bill copy. Okay, so let's jump into number 7 on Bill. This isn't odd. Let's do this example. Looks like what? Looks like what? What you're going to do, step 1 is going to solve for the trigonometric identity. What? The trigonometric ratio. Mary Beth, what trigonometric ratio do you see in this particular equation? That's true, Mary Beth. That particular trigonometric equation has a sign. So step number 1 in solving this, step 1 is to isolate the trig equation. The trig ratio, let me put it's trig equation. Isolate the trig ratio. And why did I write thug? I don't know. I apologize for that. Isolate the trig, not thug, ratio. And I'm going to underline right here is the trig ratio. So I'm going to treat that. So if I'm going to solve this trigonometric equation for the trig ratio, I'm going to treat that sign of theta right now as a variable. And the first thing I'm going to do is subtract 3. And I don't need to show all of this work. But if I subtract 3 from both sides, 2 minus 3 is -1. Now I'm going to treat that as an equation. 2 times something is equal to -1. And then that's going to tell me that the sine of theta is equal to -1/2. Now I have isolated the trigonometric ratio. What I'm going to do now is I'm going to take my eyeballs and I'm going to look on the unit circle. And I'm going to find the thetas and keep in mind thetas that satisfy the equation. Satisfy this equation. Okay, I'm going to pause the video for a minute. So, Mary Beth, can you give me an angle such that the sine of that angle is equal to -1/2? Yes, you're correct, Mary Beth. One of the angles is going to be 7/6 pi because the sine of 7/6 is equal to -1/2. Jolene, can you give me another angle? Jolene?
11/6 pi.
Oh! Sorry, video land. I meant to do this. Okay, so now we're going to look at number 9. Number 9 says 4 cosine squared theta is equal to 1. And I want to find the thetas such that 4 times the square of that cosine of theta is equal to 1. Step number 1 again is to isolate the trigonometric ratio. And you are correct again, Jolene, that the trigonometric ratio is cosine, so we need to isolate that. Step number 1 would be to divide by 4. And I always like to put parentheses around my variable so I know what's going on. This is 1/4. And now I'm going to go to the beginning of the page, and I want to know what cosine is. So I'm going to square root both sides. I'm going to square root cosine squared theta. And I'm going to square root 1/4. So the square root of cosine squared theta is the absolute value of cosine. The square root of 1/4 is 1/2. Now, since I have this absolute value, that means cosine can be positive or negative. So this equation here says that the cosine of theta is equal to 1/2, or the cosine of theta is equal to negative 1/2. What is the step now, Mary Beth? What do I do now, Mary Beth? So now, Tommy Beth said to look at the unit circle, and now we want to know the thetas such that the cosine theta is going to equal 1/2. Problem. Okay, and we notice that we want the cosine of theta to equal 1/2, or the cosine of theta equal negative 1/2, and we know that therefore theta is going to be pi over 3, cosine of pi over 3, looking at my unit circle, is 1/2. Cosine of 2/3 pi is going to be one of these negative 1/2s. Cosine of 5/3 pi is going to be what? Positive 1/2, and the cosine of 4/3 pi is going to be negative 1/2. We've just solved another trigonometric equation. Again, I'll bet you that there's that entire problem. Scale of 1 to 10, not that difficult. If you need to pause the video and write that down, you can. We're going to go on to the next problem. We're going to do as many examples as possible. So now we're going to look at number 11, which is another odd off a bill. And what I would like for you to do before you do anything else, try to isolate this trigonometric ratio sine of theta. I'm going to give you a few minutes to work to try to isolate sine of theta. If you're out there in video land, just pause the video and see if you can do it. Let's learn from this virtual lesson. Okay, so you did a very good job on this one, Jolene. We're going to add the 1, and we're going to have 2 sine squared theta is equal to 1. Therefore, the sine squared theta is equal to 1/2. I'm going to square root both sides. Square root of sine squared theta. And the square root of 1/2, the square root of 1/2 is going to be 1 over square root of 2. And I know that that's going to be square root of 2 over 2. The square root of sine squared is going to be the absolute value of sine of theta, which is going to be the square root of 2 over 2. Therefore, that equation there tells me that the sine of theta is going to be positive square root of 2 over 2, or the sine of theta is going to be negative square root of 2 over 2. And now what do I do? What do I do now? What's the step now? Look at my unit circle and find the angles such that the terminating points of y is square root of 2 over 2. And we know that those angles are theta is equal to pi over 4, 3/4 pi, 5/4 pi, and 7/4 pi. The last two are going to be, the sine of those two angles will be negative square root of 2 over 2. The sine of those angles will be square root of 2 over 2. Let's do a little bit of a different type of problem now. So let's pause the video and get ready to do that. So now we're going to do a little bit of a different problem where I have the sine of 3 theta is equal to the 1. There are different ways to approach this, Betsy Sue. Brenda Lee. My way is to let 3 theta be a single variable. So I'm going to off to the side here and say, hey, I'm going to let, it makes it easier for my simple brain to think about. I'm going to let A equal 3 theta, because I already have the trigonometric ratio solved. This is going to be, you probably wouldn't need it on this simple of an equation, but when they get a little bit more difficult, this might be a really nice hint to use. I'm going to let A equal sine of theta, and then I say, hey, the sine of A is equal to -1. Now now I'm going to look at the unit circle, and I'm going to say, hey, what does A have to equal so that the sine is -1? I will ask Betsy, can you tell me what A will be if the sine of A is -1? I'm going to look at my unit circle, and I'm looking at my unit circle, and Betsy, you are correct. It's going to be 3/2 pi, correct? And keep in mind, we want between 0 and 2 pi. So A is 3/2 pi. That's what A is going to be. Well, what's A? What did we define A to be? 3 theta, correct? So if A is 3/2 pi and A is 3 theta, and we ultimately want theta, so now I'm going to say, hey, 3 theta is equal to 3/2 pi. And now I'm going to do some simple algebra and solve for theta there. And what are we going to do? We're going to divide both sides by 3, and theta is going to be pi. Another problem along the same lines, I have the cosine of 2 theta is equal to -1/2. Again, I'm going to use Lee's philosophy because Lee is simple-minded. And I'm going to let A equal 2 theta, and I'm going to say, hey, the cosine of A is equal to -1/2. I'm going to look at my unit circle, and I'm going to say that, hey, A then is going to be equal to 2/3 pi, and A is going to equal 4/3 pi, straight off the unit circle. True or false? Going to be true. And so if I let A equal 2 theta, and ultimately I want what is theta, I'm going to let 2 theta, which is A, equal 2/3 pi. Solving for theta, Mary Beth, you betcha, divide both sides by 2. Theta is equal to pi over 3. Putting in 2 theta here for this A. Dividing both sides by 2, theta is going to be 2/3 pi. And I can always check my answer. I have theta is equal to pi over 3, theta is equal to 2/3 pi. If I put those into the original equations, and I'm going to see that my answer are indeed true. We will do some more of these equations